Hello guys, this is Miss Richardson and this video is for the wonderful, very intelligent Algebra 1 students. I'm so glad that you are watching this video so we could talk about your week. So this is for the week of September 14th through 18th. Your first test is this week. It's on Friday. So we are going to have a Zoom review on Thursday. So make sure you join me for the Zoom session on Thursday. On Wednesday, you guys are taking a practice test. I'm going to see how you do, see which kind of problems we need to go over. And then when we get together Thursday at 11 o'clock, we will discuss those particular things and see what other questions I can answer over your upcoming test. So let's see what you guys have to do this week. I thought I would start dating lessons, so maybe it would help you as far as your schedule that you come up with. If you do these lessons when I suggest them by the dates that I put on them, then that means you'll have one lesson each day, and by Friday you'll be done. You don't have to worry about any more math over the weekend. So this week you're going to be translating, which means you're going to be sliding figures on a coordinate plane. Then, so I put that Monday's date on that. And then Tuesday, you're going to look at algebraic properties and equations. So y'all remember distributive property, associative property, commutative property, and maybe one or two new ones you haven't looked at yet. And then you guys are going to have your module review and practice test. So that's for Wednesday. And then of course the spaceship is the actual practice test. Now the test itself is going to be Friday the 18th.
Sarah York, please call extension 1104, Sarah York.
Sorry about that. So your actual test is Friday the 18th. So if you notice there's no assignment for the 17th, and that's just because when we get together on our Zoom meeting on Thursday, we will be reviewing for that test. So the test is in two parts on Friday. I will make that live on Friday, so make sure you get that done on Friday. All right. So let's see if we go into this week under what do I do this week. I don't think there's anything special there. I've just basically made a copy of what I just talked about with those dates. My video will be right here. At the bottom it says, hey, let's Zoom. We will review for Friday's test during this week's Zoom meeting. So make sure you attend. It'll be on Thursday at 11 o'clock. And then I'll put the link there. And of course, your password will always be algebra. All right, so there are a couple of things I wanted to talk about or show you. So I'm going to pull up my whiteboard and show you a couple of things. So where's my pen? Here we go. So of course you guys are probably very familiar with the distributive property. I know you've been using that since distributive. I can't spell and write at the same time. Distributive property. I can't spell and talk at the same time. That's what I meant to say. All right, so you guys have been using distributive property for a few years now. So for example, if I give you this, you guys already know that you distribute that 2 to everything in the parentheses. So 2 times A is 2A. 2 times negative 3 is minus 6, and 2 times positive B is positive 2B. All right. The other property, one that I don't know if you're very familiar with, I made a note of it, is called the transitive property. Transitive property. And this might be a new one for you. So it says something like this: if x equals 3 and 3 equals y, then what must be true? Then that means that x is equal to y, which makes sense. If the value of x is 3 and the value of y is 3, then obviously x is equal to y. So that makes sense. It's simple to understand, but you probably haven't heard that word before, transitive property. So you will be looking at a couple of examples like that, and you have to identify that property. And then, of course, we have commutative, and the other one is the associative property. So commutative just means that you are moving things. Like if you commute to school, you go from your house to the school. So even if one day you had some traffic outside and you decided to go a different way, you're still going to get to the school. So that means that if I add 3 and 4, if I add 3 and 4, I'm going to get the same answer than if I add 4 and 3. In other words, you can rearrange values with addition and multiplication and get the same answer, right? Same thing with 2 times 6 and 6 times 2. Both of those equal 12. So there is commutative properties for addition and multiplication. However, that's not true with subtraction and division. If you change the order of the numbers with subtraction and division, you don't get the same answer. Okay, so that's both of these are only true with commutative and, commutative and associative is only true for multiplication and addition. So associative is basically like who your associates are, who is your grouping, who are your friends, who do you hang out with. So if I say I want to add this problem and I want to force you guys to add these two numbers together first and then add 4 to it, but then the next problem I say, actually, let's add the last 2 values together first and then add 3, we're going to get the same answer. So if you notice, the numbers and the variable in this situation are in the exact order. I didn't change the order. All I did was change the grouping, and I'm going to get the same answer for associative and also multiplication. So associates is the grouping, who you hang out with, who your associates are. Commutative is like commuting or changing the order of the numbers, and you get the same answers. So I know that you guys are probably already very familiar with those, except maybe transitive. Another thing I wanted to look at is when you guys get to the translating lesson, that means you are sliding figures on a coordinate plane. That's supposed to be a triangle. Obviously, it's an ugly one. All right, so if you're sliding a triangle, we're not rotating, we're not flipping, we're not making it bigger or smaller, we're just sliding it either left or right or up or down. So what happens? So let's say that this point A is at, that's supposed to be just a little slash. So let's say point A is at 1, 2. 1, so go right 1 up 2, and there's point A. What if I translate this triangle 4 units to the right? 4 units right. Well, what happens? What happens to these coordinates? Do both of them change? So the x-axis, I can only go right or left on the x-axis, correct? I can go up or down on the y-axis. So if I'm moving left or right, my y-axis values don't change at all. But my x-axis values change, because if I'm going right, those numbers are going to increase, because to go right on a coordinate plane, you need a positive number. And what if I went 4 units left? How would my coordinates change? Well, to go left on a coordinate plane, I need a negative number. So if I started with A and I wanted to move right to get to A prime, then I'm going to add 4 to my existing x value, which means A prime will be at 5, 2. right? If I move this 4 places, my A prime will be at 5, 2. Well, what about this one? What if I start with my original triangle and I move left 4? How is my X value going to change? It's going to decrease by 4. So A prime going to the left would be 1 minus 4 is negative 3, and my Y value wouldn't change because I'm not going up or down. Okay? So to go right on the coordinate plane, your value increases. To go left, it decreases. Well, what about moving up or down? So let's say we move up, let's say 5 spaces, and then we'll say, what if we move down 6 spaces? So let's look at letter A. So what if I move this whole triangle up 5 spaces? Well, my X value is going to stay at 1, isn't it? Because I'm just moving up. So I'll always be at 1 on the X-axis, but I'm going to move up. So I'm no longer at 2 on the Y-axis. I'm going to go up 5 spaces. So my Y value would increase by 5. So A prime would now be at 1, 7. Right? And then what if I go back to my original triangle and I'm going to move down 6 units? Well, once again, my X value is not going to change. I'm still going to go right 1 from the origin. This time I go down. So 2 minus 6 is negative 4. So that is my new coordinates by translating up or down. So hopefully that makes sense to you. All right, what else did I write here to talk to you about? All right, let's look at a problem like this. You'll have a couple of these. Let's say I give you this crazy looking distributing a fraction. And you absolutely could distribute that fraction by multiplying everything in the parentheses by 1/4. But most of us don't really like fractions. We're like, oh, I don't want to multiply. I don't want to multiply a whole number by a fraction. So I'm just going to show you one way you can get rid of that fraction. So one way to make that fraction equal 1 is to multiply it by its reciprocal, right? What's the reciprocal of 1/4? Well, it would be 4 over 1, right? So everything cancels and we end up with 1. So if I want to get rid of that fraction, I'm allowed to by multiplying the entire equation by 4. So if I do the same thing to the whole equation, it's okay because it's still equivalent. I have to do it to everything though, which means I have to multiply this side of the equal side by 4 and the other side of the equal sign by 4. So multiplying this side by 4 just simply means that these cancel each other. Make sure you do it to the other side too, though. The other side of the equal sign. So now I got rid of my fraction, so I bring down what's in the parentheses. And this time on the right, I'm multiplying 4 by 4 and I get 16. And then I'm going to solve this the same way I would if it were just a regular 2-step equation. Going to add 14 to both sides, bring down my 2x, bring down my equal sign. That's 30. What's the opposite of multiplying by 2? I'm going to divide both sides by 2. So x is 15. Got it? So like I said, you could distribute that 1/4 and that's fine. You can do that. But if you don't like fractions, you want to get rid of them, you can do that too as long as you do it on both sides of the equal sign. All right, so let's look at one more. Let's look at 1/2 times 4x minus 6 equals 5. All right, once again, like I said, you could distribute the 1/2, which on this problem would be simple to do because you know half of 4 and half of 6. But just for consistency, let's cancel out the 1/2 by multiplying it by its reciprocal. What's the reciprocal of 1/2? That would be 2 over 1, which is 2. So I'm writing this twice just so I remember to multiply both sides of the equation by 2. Well, 1/2 times 2, everything cancels, and I'm left with 4x minus 6. And then on the right side, 5 times 2 is 10. Now to get rid of minus 6, I'm going to add 6 to both sides. So I'll bring down my 4x equals 16. And then, of course, I divide both sides by 4, and my answer is positive 4. Okie dokie. Very good. Okay, one more thing I was going to talk to you about. So let's say I have a little word problem where it says something like Jill is 4 years younger than her brother. Her brother. Find the sum of their ages. All right, so we have two people, correct? We have Jill and we have her brother. So we know a little bit something about Jill's age, but we don't know anything about her brother's age, right? Nothing. We don't know anything about her brother's age. So her brother's age, I'm just going to say, is equal to B. And now, compared to her brother, Jill is 4 years younger than him. So if his age is B, how do I write 4 years younger than B? Would be B minus 4, right? Because you got to take his age and subtract 4 from it, which is what this looks like. Well, so if this is her age and this is his age, the problem tells us to find the sum of their ages. So that's exactly what we're going to do. We're going to add Jill's age plus her brother's age, because sum means addition. We don't know what the sum of their ages is, so we can't set it equal to anything, but we can simplify this expression. We have 1b plus 1b equals 2b minus 4. And that's the final answer because we have no idea what the sum of their ages is. Okay. All right, so those are just a few things I wanted to talk to you about. Hopefully that'll help you later in the week if you need to come back and watch the video when you're on those particular sections. And then just a reminder, read every page, don't skip anything, practice every practice problem, watch every video, come to every Zoom meeting. If you have exhausted all of your options of going back through a lesson, watching the videos again, you know, possibly Googling something or using Khan Academy or some, you know, good, reliable resource to help you figure out how to do a particular math problem. If you can't get all that stuff on your own, then let me know and I will help you. I can set up a Zoom with you and we can go over some things specifically that you're having trouble with. All right, guys, I hope you have a great week and I will see you all on Thursday. All right, I'll see ya. Bye.